Great, thanks. Thanks for the introduction, Tim, and thanks everybody for joining this talk today. So I'd like to talk to you about careers in geosciences, and from my perspective of being a Rocky Mountain geologist, I've spent most of my careers in the Rockies, and I also have a lot of friends, colleagues, folks I've met since I've been in Denver that work in other geoscience professions, and so I would like to share insights from my career, my profession, and then some of the other ones that are actively engaged in hiring and recruiting geoscientists now. So I probably have about half an hour's worth of information, maybe a little more, and then hopefully there'll be time for a few questions. Okay, so a little bit about me. So do you see the bar up on top? Is that kind of annoying?
It is not annoying.
I'll see if I can hide.
It's not blocking your slides, so.
It's not,
yeah.
Okay. All right,
Yeah.
good. Let me just get my pointer on here too. Okay. So I grew up near Hamlin, New York, which is in western New York State, near the town of Rockport, right on Lake Ontario. And I graduated from Oneonta on a blustery, windy day in May of 1979 with a bachelor's in geology. And for me, SUNY Oneonta was a great place to study geology. There was a very enthusiastic and dedicated faculty there. That were engaged in the work that their students were doing, and it certainly prepared me well for my geoscience career. And here is a photo of actually the first geology field trip I ever went on. This was the New York State Geological Association meeting was in Oneonta in 1977. The SUCO department hosted that. And so here we are on an outcrop near Albany, and you can see, some things haven't changed. We still see geos with plaid shirts, but here's a man with plaid pants, and I must say that this is probably the only field trip I've ever been on where somebody wore plaid pants. So that's a trend that has not continued. So a little bit about my career path. So from Oneonta, then I went to Bowling Green State University to get my master's degree. And then at that time, in the late 70s and early 80s in the US, there was a sort of an energy crisis. There was a shortage of oil and natural gas, and gas lines were long, prices were high, and there were a lot of career opportunities for geologists in the petroleum geosciences. So that's what I did for my career. I began my work with Marathon Oil Company in Casper, Wyoming, and that was my introduction to the Rockies. I worked there for 7 years. Eventually moved down to Texas and worked in 2 different offices for Marathon for about a 10-year period, Houston first, and then in Tyler. And then in the mid-1990s, I had an opportunity to move back to the Rockies, and I moved to Billings, Montana, where I worked actually for about 20 years, largely with a company called SM Energy. And then in 2015, I moved to Denver with SM Energy to take a position as their vice president of exploration. And I retired there just a few years ago. So my career was roughly 40 years, and with about 30 of that being in the Rockies. But I would say my career is still continuing as a geologist. So as Tim mentioned, I'm the past president of the Rocky Mountain Association of Geologists. This is a geology association headquartered in Denver that consists of about 1,400 members. And we do a lot of things. We put on conferences, we put on workshops and short courses, field trips. One of the things I'm very actively involved is coordinating and then actually running some field trips. I run a Denver building stone field trip, and here's a picture of me at a church in downtown Denver that is constructed from rocks from the Lion Sandstone. And the Lion Sandstone is a Permian age Aeolian sand. And there's some really nice cross beds that I'm pointing out right there. So that's enough about me, but let's talk about careers in geosciences. So really through my association with we'll call it RMAG, the Rocky Mountain Association of Geologists, I've got to meet geologists that work in a variety of professions in the Rockies and actually throughout the U.S. And so I'm going to touch on about 6 of these career types in addition to petroleum exploration, and talk a little bit about the type of work you would do, and then perhaps what the outlook is for careers in those industries. And then I'll finish up with some thoughts about hiring trends with some data from the American Geological Institute, and then thoughts on your future as a geoscientist. So oil and gas exploration and development in the U.S. Oil and gas is primarily found in 4 provinces in the U.S. One of them is in your backyard. The Appalachian Basin is a target for shale development, gas shale development down in the Marcellus, and I'm sure you've all heard about that. That's occurring in Pennsylvania, just south of you. The Mid-Continent area is also very active with oil and gas, primarily in North Texas, Oklahoma, and Kansas. Probably the epicenter for oil and gas production and activity is in the Gulf Coast in Louisiana and Texas. And then probably the largest and most prolific producing basin in the U.S. is in the Permian Basin here in West Texas. And I had the opportunity to work the geology there over the last few years of my career at SM Energy. But I'm going to talk about the Rockies. So I've spent most of my career working many of the dozen or so basins up here that produce oil and gas. And the cool thing about working petroleum geology in the Rockies is that the reservoirs that we target outcrop on the basin edges. So we can actually go to the field and see the rocks that we're drilling in the subsurface. So here's a photograph of the west flank of the Powder River Basin. And these 2 sandstone benches are the Frontier Formation, which is a Cretaceous-aged rock that is deposited throughout the Rockies. And at the company I was working for, we were actually targeting these beds at depths of about 10 to 11,000 feet deeper in the basin. And we were drilling horizontal wells in this formation. In fact, we were drilling laterals that were 2 miles long in this rock. So the advantage of working this type of geology in the Rockies then is that we can actually go up to an outcrop like this. And this particular outcrop spans about 20 miles. We can go up to these rocks, we can look at them and kind of visualize what the geology of a wellbore being drilled horizontally in this rock unit would do over a 2-mile span. We can see changes in the lithology or the sedimentology, perhaps in the bedding, or even some of the reservoir characteristics. So it's a really powerful tool to be able to see some of these target reservoirs and outcrop. Here's another trip we took to this is sort of central Wyoming or central Montana. These are the Bridger Mountains. We're on a trip to look at the Sappington Formation, which is equivalent to the Bakken. And maybe some of you have heard of the Bakken. It's the most prolific oil-producing formation in North Dakota's Williston Basin. And here, this is actually the closest outcrop to the Bakken to that basin. And so we were able to go up here. And this is actually a day in mid-September in Montana, but we had an early snowstorm, but it was still a bluebird day. You can see the dark blue sky, and had an opportunity to get up and do the same type of work, look at this formation and outcrop and understand a little bit more about its characteristics as a reservoir. Well, then in addition to being able to do outcrop work, petroleum geologists love to look at core. And for those of you that may not be familiar with core, it's where we'll go into go in with a drill rig and core a 2.5 or 3-inch cylinder of rock, bring it to the subsurface, and then slab it, which gives us the opportunity to see things like bedding and understand sedimentary structures and mineralogy a little better. So this is a core of the Frontier Formation, and here we have this particular box would be 10 feet of core from base to top, and we're looking at organic rich shale underlying a shallow marine sandstone. You can see some cross bedding, some rip-up clasts. And here are some of my colleagues. We're at the USGS here in Denver, and the USGS has a huge core repository from core from all throughout the country and even throughout the world. And this is available for us for free use. You just have to make an appointment. And then you can come in and really learn a lot more about the reservoirs that you're drilling by examining core. So, we're geologists. We just love to look at rock. But in truth, a career in the petroleum industry is largely office work. Well, you'll be doing computer mapping and modeling. There's a lot of work with stratigraphy and sedimentology, geochemistry, data science, and analytics are often involved. Job roles include wellbore geosteerers, the geologist that would actually be drilling a horizontal lateral, let's say, in one of these rock units. Development and exploration geologists are the ones that help find the drilling locations that will be pursued. Geophysicists, petrophysicists, data scientists are all parts of subsurface geological teams that work in the oil and gas industry. Employers, the big ones are the large integrated oil companies, Exxon, Chevron, Shell, and then the U.S. independents also hire quite a few geologists. You may have heard of some of these names like Devon and EOG. A career in the oil and gas industry is commodity price driven. When prices are high, things are booming. When prices are low, sometimes your job may be at risk. So it can be a bit of a roller coaster ride. But for me, it was a wonderful career, understanding more about geology, always learning about geology, and then embracing the technology changes that have come to our world over the last 40 years. So guidance for people pursuing this career for an undergrad, just get a good solid core geology background, just like the one you're getting in Oneonta. But to give yourself a leg up on perhaps having a job in this industry, you should attend a graduate school that has a petroleum geology curriculum, and there are many throughout the U.S. But there are numerous geoscience careers that require the skills that are similar to petroleum and that are starting to get some traction. So I'm sure you probably have all heard about carbon capture and underground storage, or CCUS. And that's really kind of a reversal of the value chain for petroleum geology. So, for oil and gas, we're looking for a reservoir, we're drilling it, producing it, and sending it to the market. With CCUS, we're actually going to the market. We're going to where we have emission sources, and we're capturing the CO2 and then transporting it and then pumping it back into the ground, into the same or similar reservoir where we, let's say, would produce oil and gas, or perhaps even water. So most large oil companies now have CCUS teams. And there's considerable private equity money also going into CCUS research and applications. In fact, there's a friend of mine here in Denver who's working full time doing CCUS consulting. The job skills are very similar to that of a petroleum geologist. It's all about understanding reservoirs, sedimentology, porosity, permeability, geometry. It's very much an emerging field, and maybe one where there would be more opportunities as we look in the next 5 to 10 years. Geothermal has been around a long time, but geothermal now is getting a renewed interest, since we are looking for more green sources of energy. So this is a slide from a company called Transitional Energy that is actually run by a friend of mine here who was a former petroleum geologist. And this company has a unique model. They are utilizing abandoned oil and gas wells in areas of high heat flow. So a well, let's say in this cartoon, you might have a bottom hole temperature of maybe 250 to 300 degrees, which is very hot. So what this company is doing is drilling a disposal water well into this reservoir. They're pumping water down the well bore, then using some of the existing abandoned oil and gas wells to pump this hot water, up into a production facility where this essentially the heat can be transferred into electricity using a little plant. And then, of course, the electricity can go right to the grid. So this company has a pilot project that's running in Nevada right now, and they've had some early success. And again, this is very green, and from a career standpoint, it requires the same types of skills that an oil and gas geologist would also need. And then helium exploration now is actually kind of booming. So helium is an inert gas and it has high thermal, it is a high thermal conductor. And so because of that, it has quite a number of industrial uses: cryogenics, semiconductor manufacturing, welding, constructing superconductors. It's a naturally occurring gas associated with some oil and gas reservoirs, especially in the mid-continent area and Oklahoma and Kansas, and then also in the Rockies. So there's a high demand for helium right now, and pricing is quite high, and it spurred quite a bit of exploration interest. In fact, so RMAG, our association, sponsored and ran a helium conference last month. We were expecting 100 to 200 attendees. We had nearly 400. We sold out our conference site and actually opened the meeting up for virtual attendees for those that couldn't be there physically. So again, this kind of came out of nowhere a number of years ago that the helium went out would be a commodity that is attracting a lot of attention for potentially for geoscience careers. Now I'd like to pivot and talk about mining geology and mineral extraction. Here's a photograph of an RMAG field trip we ran a couple of years ago to the Cripple Creek gold mine, which is up in the mountains in Colorado, operated by a company called Newmont. So for mineral extraction, we think about the metals, gold, silver, platinum, palladium. So there's also uranium, and now there's also a lot of interest in these rare earth elements. So rare earth elements, there are about 17 of them, and they occur in rather minor and small concentrations within ore bodies. But they're becoming very important to life as we know it today. There are all these rare earth elements that essentially go into making our smartphones. And then if we look at things like construction of solar panels, hybrid vehicles, wind turbines, these all require kind of a potpourri of rare earth minerals and elements. And so this is really driving a lot of mineral exploration for these kind of rare minerals. And again, represents another potential career path for a mining geologist. And then I also need to mention lithium. So lithium is not a rare earth element. It is an alkaline metal found typically in brines, salt waters, or in ore deposits. And there is, of course, you all know there's a high demand for lithium-ion batteries right now. They're really spurred by the building of electric vehicles. And so there's an engineer friend of mine here in town who now is consulting and looking for lithium deposits in the United States. So a little bit more about mining geology. Here's a photo of the Edgar Experimental Mine here in Colorado. This is kind of a cool place. So this is an abandoned gold mine that the Colorado School of Mines purchased. And they actually use it to teach mining, geology, and engineering classes. So believe it or not, I mean, this is a classroom. Here you have students with their hard hats sitting at their desk, and they're being taught mining and geology and engineering by this instructor. So employers for the mining industry, large multinational corporations like Newmont, and then there are quite a few small and mid-sized companies that are also active in mining. Important skills for prospective employers, and these are from another friend of mine who is a mineral geologist, being able to identify various types of rocks, structures, and alteration patterns, weathering characteristics of field outcrops. It's good to be able to recognize those, being able to render and map geological data in the correct 3D space, and really being able to think and visualize in 3D is an important skill. There are career opportunities for bachelor's and master's degrees. Master's is preferred, probably for advancement, and I think master's degrees, candidates make a little bit more money as well. Field experience is important. So if this is a career that you'd like to pursue, get as much field work and field classes under your belt as you can. Foreign language is helpful. A lot of these companies, especially the larger ones, have mines in South America. So speaking Spanish can be very helpful. But because this is commodity driven, in a career here, we'll have booms and busts. There will be times when there are tons of jobs. There will be times when job opportunities might be limited. Moving on, environmental geology and geotechnical engineering. So the information on these next few slides are provided by a friend of mine, John Fontana, who actually owns and operates a company called Vista Geoscience. So the type of work that this company does and others are environmental geology and geotechnical engineering. You would be essentially doing hydrology type work, groundwater sampling or monitoring. In this field, you might be working on soil remediation and cleanup of a spill site or perhaps an underground storage tank leak. There's engineering work involved or geological engineering work. Most construction sites now in states require some sort of substrate and subsurface examination to make sure that it is on solid ground. In fact, that's where this geoscience rig is working right now. This is a little drill rig, and maybe some of you recognize this feature in the background. This is Devil's Tower, located in northeast Wyoming. And they're actually on a construction site, and they're doing some core sampling before construction work begins. So this industry is really driven more by regulation from the federal and state authorities, and there are really fewer boom and bust. This tends to be more steady work for geoscientists. And there are jobs available on entry-level positions for smaller companies, and the type of work you would be doing would be perhaps working on a rig like this with some engineers, drilling for soil, groundwater, and gas sampling. You might be running logging tools into these shallow holes to learn more about the substrate. You might be working on injection projects to pump biological or chemical agents to treat groundwater spills or contamination. And you'll be doing the type of things that you do in your undergrad school there in Oneonta. You'll be compiling data, writing reports. And employers with bachelor's degrees tend to be smaller ones, like my friend John's firm, Vista Geochemical. But then with a master's degree, there's probably more opportunity for some of the larger environmental firms. This company, Haley and Aldrich, is headquartered in Boston. They've been around forever, and they hire master's degree geoscientists. And there you might be doing remediation research work or design, groundwater modeling, as in this picture, project management. You may be working directly with clients or working with government and regulatory authorities. Field experience in this area is also really essential and important. And often, as an environmental geologist, you would be required to be registered in the state where you work as a certified professional geologist. Geohazards now is becoming a potential career path and actually kind of part of everyday life. I mean, what a tragedy if you're living in El Salvador in this village that encountered this horrible landslide. But it happens in the U.S. too. This is a photograph of Glenwood Canyon just 2 years ago. I-70, the major interstate highway across the West, was washed out and unusable for over a month while this landslide spill was cleaned up and the highway was repaired. So this type of work is largely done by government and regulatory agencies. And the employers would be the federal government, the USGS, the BLM, Department of Interior, National Park Service, or state authorities such like geological surveys or regulatory agencies. So the work that these regulatory agencies do would be, this type of natural hazard monitoring, which would be landslides, earthquakes, even volcanism. In fact, in the state of Texas, state geologists work to assess earthquakes that have been triggered by oil and gas companies injecting water to deep wells and triggering faults and small earthquakes. Geoscientists also can be working in the watershed research and management field. Geoscientists in these areas work on natural resource assessments, both at the federal and state level, looking at water, oil and gas, minerals, metals, rare earth minerals, aggregates. And they also can be working on climate change. Here in Denver, we have an ice core facility. And there are cores from ice from Antarctica that are recording paleoclimate information, for hundreds of years of Earth's history. So there's a wide variety of work that's available in these agencies. And in fact, this is where some of the recent growth and hiring trends are occurring. I'll show you a slide about that later. Education requirements, they'll hire bachelor's, master's, and PhDs, kind of depending on program needs and the type of work that might be going on, these specific federal and state departments at the time. And internships are also available. And if you can get an internship, that's just a great way to kind of get your foot in the door for one of these state or federal agencies. Education is super important. We just don't have enough good elementary, middle, and high school science and STEM teachers, especially in the earth sciences. And RMAG really sees this as an important calling. We have a Teacher of the Year award that we award every year to an outstanding Colorado earth science teacher, and it's typically given to middle school or high school teachers. Here are some of the winners from previous years. But education is also a great way to put your geoscience career together. And of course, there are roles at junior colleges and universities as well. And then even paleontology. I mean, we all love fossils. We all love dinosaurs. But there are actually careers in paleontology. They generally require a PhD or a master's degree, but there are also some bachelor roles available. The employers are typically universities, museums. And then, the Denver Museum of Nature and Science here is a great example. I mean, it's a world-class museum. They have 15 full-time staff that are, I would say, under the category of paleontologists. They have 2 postdocs working there, and they have 30 interns that are working, actually 20 to 30 interns there, it seems, almost at any time. Many of them have bachelor's degrees, and they're working on things like fossil preparation or other research. The museum scientists published 15 scientific papers last year. So there are careers that are maybe a little niche-y, but they definitely exist. Okay, so now I'd like to pivot and talk a little bit about who are the working geoscientists and what are the trends like right now. And these next few slides are from a presentation given by Christopher Keene from the American Geoscience Institute just a month or two ago. So this is a snapshot from 2017 looking at U.S. geoscience employment by the highest degree. You can see that the majority here are in the master's category. That seems to be kind of the sweet spot. But there are a large number of bachelor degrees, geologists also working, and PhDs, of course, to a bit of a lesser extent. And then these lighter colors are interesting. These are folks that are working as geoscientists, but they do not have geoscience degrees. They've crossed over, probably from another physical science. But I think the important takeaway here is, and also from this presentation from Christopher, is that at any given time, there are 250,000 to 300,000 geoscientists working in the US. And when people like me retire, that opens up another chair for somebody else. And so, I think there are just great opportunities for those of you that have chosen this as a career path. Here's a slide on employment sectors, looking at specifically now master's graduates over the last 7 years, or actually from 2013 to 2020. So just kind of at the beginning of the pandemic. And this just shows you how this is such a ever-changing dynamic. So 10 years ago, back in 2013, almost 80% of the geoscientists were working in oil and gas or in mining. And now, that has been greatly shrunk. I mean, the oil and gas wedge is quite low. I think some of this is impacted by COVID, but also it's been impacted by 2 things. The fact that with data science, we need fewer petroleum geologists to do what we were doing back here. And then also, there's definitely a move away from fossil fuels. And so, that is also creating fewer opportunities for those working in the petroleum geosciences. A look at this increase here in the 2 orange colors. This is federal government agencies and state agencies. So in the last 5 or 3 years on this chart, nearly 20 to 30% of the master's graduates now are working in this field. And then we looked at environmental geoscience. I don't know where AGI puts that. I'm guessing it's in one of these professional services categories. But this is a 7-year look back on career trends. And I'm just going to say that if you were to build this chart looking 10 years forward and had a crystal ball, it's going to look much different than this. We just don't know where the developing needs for geoscientists will occur, but you can bet that there will be opportunities like this and ones that perhaps we can't even imagine. And this slide I think is just very encouraging for all of you that are geology majors. So this is looking at geoscience enrollment in the U.S. over the last maybe 70 years, and it's has its ups and downs. It's a bit of a roller coaster, but really look at what's gone on since 2016. Steep downward trajectories for both undergraduate and graduate degree educations. The jobs are still out there. The geoscientists, the students to fill those jobs are going down. Some of this is driven by COVID, but not all of it. This trend existed before COVID hit. So for those of you that are majors and they're graduating, I think this is a great time for you to be in this profession, because I think you're going to have a lot of opportunities for things that you would like to pursue. So I'll try to wrap up here quickly here. So valued skills for today's and I would say tomorrow's geoscientists. Again, get a fundamental geological knowledge base that you're getting in only on to, mineralogy, sedimentology, igneous petrology, metamorphic petrology, structural geology. These are all things you need to get under your belts. But it's also good to have crossover understanding of the other physical sciences, physics, chemistry, biology. I've used all of those in my career. You'll use those in yours, regardless of what career path you choose. It's important to be able to work quantitatively today and to be able to manage large data sets. So in my career, I myself and my colleagues spent 80% of our time wrangling data, finding data that we could eventually put on a map and then map. And then we spent 20% of the time making the maps and analyzing the outcomes. So we're trying to switch that, and actually with data analytics, we're able to do that now. So today's geoscientists will be doing much less data wrangling and hopefully much more interpretation. And then here's some crossover skills that was recommended from AGI. Now, don't get stressed about including this in your undergraduate education, but these are good skills to have early in your career. Certainly programming, Python and R is a great skill to have. RMAG teaches a couple of Python classes a year. And we have a lot of early career students, early career geologists, and even students take those. And then having experience with GIS, or if you want to go into the environmental geosciences, HAZWOPER training is important. It'd be a nice thing to get under your belt. And then I've added this one, emotional intelligence. So this is a soft skill. It's something you're not going to take a class about. I don't think they're even offered. But the ability to be self-aware and to work well with others is really an important skill. Whether you're working, for a mining company or for an environmental company, or whether you're a volcanologist, it's important that you have a way to communicate and work well with others in team situations. And if you have those skills, it will serve you well in your career and in your life. And then I would say, this is more of a pitch for me, I would say join your professional organizations and local geology societies. So all geologic professions have professional organizations and associations, and they're very specific to those professions. So when you start a career, join those organizations. It's a great way to keep your skill set fresh and to build your network. And then I would also say, wherever you end up, join your local geology societies, and hopefully all of you belong to the Geology Club there at Oneonta. But again, this is a great way to build a network and just to learn what other geoscientists do. If I would not have been active in RMAG, I would not be able to share outlooks on 6 different career types in the geoscientists. But now I have friends and colleagues that work in all these areas, and it's fun to talk to them and compare notes. So I would say, join these organizations, get back to your profession, and have fun with other geos. So some final thoughts on your future geoscience career, and here's a picture from, maybe some of you are in this picture. This is from last summer's field trip to the Rockies, and everyone's pointing in different directions. So I'm interpreting this to mean that your careers are all heading in different directions, which is a good thing. So your career is going to be different than mine. Your career opportunities are evolving. Whatever you decide, pursue your passion, but be open to change that will happen through the course of your career. And then here's a recent quote that maybe some of you have seen: with every retirement, we destroy a geoscience job. And with every new hire, we are creating a geoscience job we can't even describe. So the new hires of today, and these are you that I'm talking about, you will define these new jobs of the future. So with that, I would just say work hard, stay engaged, and have fun with whatever you do. All right, thank you. And I'll stop sharing. And if there's time for questions, I know maybe some of you have other classes, but I'm certainly available to hang around.
Would it be possible for you to share those slides with us so that I could show them to students in my classes?
Absolutely. Everything here is shareable. And I think talking to Michelle Hansen, I think this talk was going to be recorded, but I'll find a way to share my slides. It's a big file set. We'll just have to upload it to the cloud, and you can download it. So we'll take care of that after the meeting.
Great, thank you.
Sure.
Rob, I have a question. So on recruiting students into the geosciences,
Mm-hmm.
It's difficult, right? The trends are showing that. We are really seeing our department has been affected greatly by this. We're down to almost 10 students in the department.
Yeah.
And it is and has been a struggle to come up with some sort of recruitment plan to get students in, and we have not been successful. And I don't know if you have some comments or suggestions. I think students are just unaware. I mean, potential students are unaware of it. They're not interested in it because everyone thinks it's gas and oil, and the generation that's coming through, right, Gen Z, they're all about the earth and sustainability. And
Correct.
technology seems bad in a way, maybe. I don't know. We have struggled since I've been chair since 2019, and we have just been struggling, and we cannot figure out what to do.
Well, so I think you're seeing, in your department, you're seeing the same things around that one of the last slides I shared, that all geoscience departments across the country, unfortunately, seem to be kind of going through the same thing. So I put a link to that AGI talk on this presentation. So I think that was really beneficial to me to be kind of aware of what's going on in that space, but then to also see that there are opportunities. I was amazed at the number of jobs that are now being created in federal and state agencies. I was not aware of that. And the comment that was given in the presentation was that some of that was kind of COVID driven. There were a lot of retirements, and so these agencies were needed geoscientists to replace these ranks. So I think, Lee, I would recommend watching that presentation, and I think there's data there that that could be used to. And so it's all about jobs, right? It's all about what can I get a career in that's going to be meaningful to me and beneficial to my community. And so if you can get some of that information from that slide presentation, that would be my first step.
And so that, in case you didn't know, our geology program is actually a professional geologist licensure qualifying program for the state of New York.
Yeah, I saw that on your website, and that's great because these regulatory jobs, pretty much all of them require professional certification. So you're essentially preparing folks for the test, right?
Right, yeah, they can take it. Most of them with their credit, with their semester hours, they can take it their senior year, their spring semester of their senior year, they actually can take the test.
Great. So I'm curious, what is the passing rate like? Are most students able to pass it the first time through?
I don't think we've had anybody go into it.
Okay.
Ones that already went out.
Yeah, I would say our past graduates from 2015 and 2010, 2015, those geologists are now starting to get on it. And we have actually provided, Jean Florentino actually came here to give us a workshop on professional geologists, and just none of our students, I think they see the benefit, but I guess, I don't know what it is. That I have not heard of anybody that has reached out to me about wanting to take this exam.
Well, yeah, again, that's just, I guess, awareness of what the benefit of having that certification. The best time to take it is just when you're graduating, because all that information is kind of fresh in your mind. You know, folks that start work and then have to go back and try to remember what they learned, 5-10 years ago. It's a little more challenging. So, yeah. What about so the the New York State Geological Survey? I take it as probably located in Albany. Do you have any exposure to what those folks do? I wonder if you can invite any of them to come and give a talk at Oneonta.
They were pretty much stripped down. There's not that many of them left at the museum anymore.
Yeah.
But they are doing a lot of surface geology mapping across New York with this high resolution LiDAR data that we have now, and mapping all of the glacial deposits.
Cool.
And they have contacted me a couple different times to ask me to get a master's program going to send geologists there to map, because there's just no programs in New York State now that are developing mappers. Unfortunately, our school was not very supportive of a master's program for them at the time. That may have changed now. So, so there's some challenges on our end, both from the institutional support side and just making students aware of what the possibilities are. I think. We're somewhere caught in that middle, and we need to move forward and fill the gaps. I don't know how.
Well, yeah, I know that indeed is a challenge, and I think that recruiters tend to spend their time at master's programs, so the undergraduate programs just don't get the the airtime from industry regarding what type of geoscience profession it is. So that's kind of the challenge you have is trying to find ways to make those connections. So I understand. So those of you, go ahead.
I just want to say thank you for using the 2 pictures from the renamed Western field trip.
Cool.
On that. So Chris Komarski, who is actually one of our meteorology faculty, but he does geology because he has a degree in geology. Goes on the trip and we have a great time. And yeah, we're running it again in 2024.
Super.
So maybe we can reach out to you when we're as we're planning it.
Yeah, if you're coming through Denver again, I'd love to connect with you. At Dinosaur Ridge or Red Rocks, I do little Front Range field trips. So be glad to connect and show you some Colorado rocks. I would love to do that.
All right, excellent. I'll definitely do that because we are starting to plan for that trip.
Okay, super. Yeah, Red Rocks is just a really cool place. I mean, everyone's heard of the music venue, but the rocks there are amazing. And here you have essentially Pennsylvania and Permian rocks, sitting on 1.4 billion year old granite. So the great unconformity is alive and well at Red Rocks. So it's a fun,
it certainly is. I love going there.
fun place to visit. So great. Okay. Well, look, I'll connect with Michelle and find out a way to get these slides to you. And if you have my email, so I feel free to reach out anytime. I'd love to help you, and even joining an organization like RMAG. I mean, we have online classes. We have a monthly newsletter. We have luncheon meetings that you can attend online for, I think it's only $10 to dial in. So I'll give you some information about RMAG as well, and that could be another piece of networking that might help somebody in the long run.
Yeah, that sounds great. We really appreciate it, and your viewpoint is extremely helpful to us.
Okay, super.
As we're countering and trying to overcome some of these issues.
Yeah. Well, I would say again, that AGI presentation was very enlightening to me. So maybe there might be some good takeaways there that would kind of help you plan for your future too. So
I think so. Well, thanks for your time.
all right, you're welcome. All right, take care. Enjoy your nice spring weather. All right.
Summer weather.
Yeah, here too. So it was 82 here when I started the talk. I don't know what it is now, but we broke records in Denver both yesterday and today. So it's hot.
Wow. Everybody's breaking records.
Yeah, it's scary. All right. Well, take care. Nice to meet you all.
Thanks again, Rob.
Bye-bye.
Bye.
I know that because
I'll be in.